Because if we think about the whole performance tuning process that we go through today, it's really a continual life cycle. As soon as I go and improve performance in one area, we're going to then have performance be degraded in another area. And it may not necessarily be degraded, it may be that all of a sudden it rears its head that we didn't see that before. We've gone and resolved these issues, so we've now got these other issues. But you need to start to think about performance tuning as a law of diminishing returns. So there's only so much performance tuning that you really is going to get any value out of. But I always like the whole Pareto principle of the 80-20 rule, because I know that 20% of my queries are going to be causing 80% of the performance problems that I have. And this is a methodology that I follow all the time when I'm working with a customer in order to then define what the issue is and how do we go about resolving it. Because I can't resolve the issue unless I know what the outcome the customer is expecting. Like if they've got a web page that's taking 3 minutes to load, they might be happy to get that down to 10 seconds. Is there any point in me actually then spending all of this additional time to get it down to 0.001 of a second? Probably not. We need to define what the outcome is. So when have we actually reached what we call our exit strategy? So we've got it down to exactly what the customer wants. Yes, they can re-engage and we can then look at the next level of performance, but they were happy with 10 seconds. And they might be happy with 10 seconds is because there's no human interaction. It's just simply a ticker that's sitting on a plasma screen, sitting on a wall somewhere. It's not a web page that people are interacting with. So the first thing I do is I go and define what the problem is. I go and set the goals. So this is, what are we trying to actually achieve? We've got some performance here. Let's focus on these areas. We then go and look at monitoring that for a period of time. And then we start to analyze that. And that's our triage process. Now, I use the word triage because I think although it's a medical term, it's got a great example in SQL. Because if anybody's been through an emergency or an ER ward, you've basically got what's called the triage nurse. Now, that triage nurse at the front is the gatekeeper. Now, as you come in, your legs falling off and things like that, they determine where in the hospital that you need to go. If you come into the hospital and go, look, I've just got a little bit of a headache here, a bit of a sore tooth, what can you do? They then triage that. But in a disaster situation, that triage nurse has got a pack of coloured cards that sits behind that. So, for example, in a mass incident, maybe a bus crash or something like that, where there's a large number of influx of patients that come in, they have these coloured cards. So as they come in the back of the ambulance, that triage nurse goes, black card, red card, blue card. And that determines what happens to that particular person, what process they're actually then looked at. Okay, that person unfortunately is going to die, we're going to leave them over there. And it's a horrible thing to say, but also we might go, look, a blue card typically indicates this person has cardiac arrest issues, so there's possibly an issue there that we need to actually get a defibrillator, we need to get a team on that. So, and that's what we want to do from a SQL perspective, is get our coloured cards and go, look, that query over there, we don't need to focus our attention on that, that application's going to get upgraded, this query over here is not causing any performance. Look, that one's been executed lots, is that what's causing our issue? Because we don't want to focus our attention just on the really bad performing queries. Because if we think about the bad performing queries, often those bad performing queries are occurring during a batch process. They're a long running 2-hour process. No one's being impacted at between 2 and 4 in the morning. What I want to focus on is what's impacting the end user. If I can go and take a 3-second query and reduce that down to half a second, that all of a sudden means that somebody is getting very instantaneous response. So think about working with a CRM system. So if an organisation's got CRM and they're working with it day in, day out, that couple of seconds is going to cause huge impact across the user population, where that really bad query overnight has no impact. So we need to think about getting our coloured cards when we start to go and analyse all of our SQL instances. We then go and define the solution. Is it our SQL Server Go Faster switch that we're going to implement? Is it that we're going to put an index on? Or is it we're going to change a query? Or what is it that we're going to do? So we want to identify what that is, and then we want to test that. We want to make sure that whatever we're doing is not going to have any additional performance impacts on our server before we go and put them straight into production. And then we deploy, review, and then we continually go through this whole cycle again and again. The problem I have when I work with SQL is what tool do I use? So I walk into a customer, performance problems, I've got my little backpack on of trusty little tools. What tool do you guys look at first? Has anyone got a favourite one listed up here? Error logs, yeah, so there's a problem going on, yep. So check the SQL Server error log, check the Windows event logs, yep. Check maybe even the SQL agent logs and things like that. Anything else? Now there's one up there that I use as basically my golden tool, time in, time out. And can anyone think what that might be? It's listed in the first column. The first thing I typically start to look at is I look at the bottom one there, weight stats. So what is weight stats? Well, think about walking into the supermarket. I've got a number of people in the 8 items or less standing in front of me. I've got some clown with 12 items. I've got someone with a whole shopping basket. But I've had to go and wait. Every time SQL Server has to wait in a queue, it goes and writes into weight stats. So is it because I was waiting on network? Is it because I was waiting on disk? Is it because I had context switching like CX packets because max degrees of parallelism wasn't set correctly? No matter what it was, basically every time somebody comes into that 8 items or less queue and they don't get the opportunity to go straight through to the checkout, we actually go and record we waited in this queue. We record how long we waited in the queue and what caused it. Was it because there was a price check in aisle 8, or was it because of something else, the FPOS machine was broken? So all of these things get recorded in weight stats. So we can very quickly isolate what's causing the current performance issues, but also historically what's caused all of the issues as well. The thing to be aware of when we look at all of our dynamic management views, and weight stats being one of them, is that they're only as good as the last time the SQL Server instance service was recycled. So if I stop and restart the SQL Server service, all of these stats are cleared out. Or if I reboot the server, all of these stats are cleared out. So it's only since the last time that the SQL Server service was available to us. So what I'm going to do is I'm going to walk you through my Chuck Norris takedown script. So this is what I do when I walk into a customer. I want to identify what's happening. What we're then going to do once we've looked at the Chuck Norris script is we're then going to look at a real-life performance tuning problem. So we're actually going to create some performance issues right in front of you today and walk through as a group how we can very quickly do that. Because what I want you guys to have the skills to take away with you is how you can start to leverage the dynamic management views inside of SQL Server to more effectively monitor and manage those SQL instances that you have today. So let's have a look at my takedown script. So I'm just going to open up Management Studio here, and here's my takedown script. Now, the first thing that I want to know is I want to know what version of SQL Server and what operating system is it that I'm dealing with. So, is it SQL 2000? Is it, no, what OS is sitting under the bottom? Because we want to know that, because we want to make sure that we've got the appropriate operating system, not just the appropriate SQL instance. So there's no point in going and putting SQL Server Data Center Edition on SQL Server Standard Edition, because if we've got all of these additional resources there, we're not going to be able to address them, because each edition of Windows has limitations the same way that each edition of SQL has limitations on memory utilization. So the first thing I'm going to do here is I'm just going to do a select at version, because when I do that, it's going to then give me not only the SQL version, but it's also going to give me, I can see that it's an x64 platform, so I know straight away it's 64-bit that I'm dealing with, and I can also go and see what build of Windows that I'm dealing with as well. I can see that Windows has been Service Pack, so we're running Service Pack 1 on my machine here at the moment. But what's the problem with that build number for SQL Server? Because you guys know your build numbers all off by heart, don't you? Sorry? Exactly, that's an RTM version. That's the RTM version of SQL Server 2008 R2. Just be aware that Service Pack 1 has been released for R2. So for those of you who are sitting on SQL 2000 going, look, I'm all good because I'm on Service Pack 4. We're not going to move to R2 until it's on Service Pack 1. We've got no excuses now. Service Pack 1 has been out since the start of the year for 2008 R2. So that's what I want to look at. Okay, what am I dealing with here? Because that's then going to determine, can I actually run the rest of this script, or do I need to go back to old school and pull out Profile and things like that? So the next thing I want to do is I want to get an overview of the hardware that's running. Now you might be saying to yourself, why do I want to have all of this coded? Why can't I just go and click around and go to System and get all the information that way? Well, I want to get it all in one spot. Now yes, one of the things that a lot of people do is they go and click on Activity Monitor here. And they click on Activity Monitor and SQL is going to sit there and it's going to get all that information, but it's not going to get it down at the detailed level that we want to actually be able to drill in. And that's why we want to start to pull out the DMVs and start to utilize that information. So the next thing I'm going to do is get an overview of the hardware that I'm running here. So you'll see that on my machine I've got 2 logical CPUs. but I've actually got one physical CPU. So what I've got is a single socket that's dual core, and I can see how much memory I've got, and also when the last time the SQL Server service was restarted. That's then going to tell me how soon, like how much history I've got inside of my dynamic management views by looking at that. Now that was something that was introduced in SQL 2008, the ability to look directly at the DMV and get the last time SQL Server was started. So you old school guys that are running 2000, keep enjoying looking at when TempDB was last created. Okay. So I also want to have a look at my memory allocation as well. So I want to look at the physical memory that I've got allocated to SQL Server, but really what I want to look at is I've got two counters across here. I've got process physical memory low and process virtual memory low. They're bit indicators. Is memory low? Yes or no. In this case, on my machine at the moment, memory is not low, so I can tell straight away I don't have a problem with memory because SQL Server's got enough memory. If it had memory pressure there, those would either be 1 on the virtual memory or 1 on the physical memory. So straight away, I can identify is memory an issue. So the next thing I want to start to take a look at too is I want to start to take a look at configuration information. So traditionally we'd use sp_configure to go and see configuration information. The problem with that is we need to enable the advanced options and do a reconfigure with override, and even that didn't show all of our options. We've actually got our sys configurations that we can query directly from, and that's going to give us all of the configurations that are set on this particular machine. Now there's a number of things that I look at for straight away when I'm working with a customer. The first thing I want to look at is have they enabled lightweight pooling. So it's a non-default option, but it causes significant performance issues around context switching with the CPU. I want to look and see if the max server memory has actually been set. So are we just going to give SQL Server everything, or how are we going to do this? Because we want to think about the way that we allocate memory. SQL Server is very greedy. It wants to take everything. Now, do I want SQL Server to have everything? Well, I've got other things running on the box, including an operating system. So even though I mightn't be running any other applications on my box, I want to make sure that I'm not having to go and do an interrupt request. Hello, can I have some memory back? And then SQL's got to deallocate that memory and then allocate that again across to the operating system, which causes performance issues. So we normally set a maximum memory that we have inside of SQL. So rule of thumb, let's say for example we've got 32 gig of memory, we'd probably go and allocate 28 gig for SQL and allow 4 gig. So that's sort of a bit of a general rule of thumb. Leave about 4 gig available there for the operating system when you've got higher amounts of memory. At lower amounts of memory, you can then go and leave lower amounts for the operating system. So things that I'm starting to look at. Because the other thing I want to have a look at is when I'm also creating that memory allocation, I want to also look at locking the pages in memory. So by locking the pages in memory, it means that the SQL OS is now responsible for its own memory management. So SQL itself has got what's called SQL OS. It's got its own mini operating system. That mini operating system can actually bypass the Windows operating system and hit the underlying hardware itself. So by locking the pages in memory, we're dedicating this block and chunk of memory all dedicated to SQL. We're not going to have to worry about moving memory management around and things like that. It's all dedicated directly for SQL there. So in order to do that, you actually need to go and change the local group policy of your machine. You go and change the local group policy and you go and add the lock pages in memory role under security to the SQL Server service account, and then you need to stop and restart the SQL instance in order to then go and allocate that.